let's talk about unit vectors. Specifically, I want to get into how we can use unit vectors to express other vectors in a convenient form. But first of all, let's look at what unit vectors actually are. So unit vectors are simply vectors that have a magnitude of 1. And that's the definition, that's basically the gist of what a unit vector is. Now, they're often used to define coordinate systems. So if I draw an xy coordinate system, we usually define a unit vector along the axes of that coordinate system. So x and y, like so. And these have, these have magnitudes of 1, both of them. And so they're unit vectors. And so this hat you see is what that you put above the vector is what denotes it as a unit vector. And I've actually written it like x and y, but if you have, say, x, y, z, common notation has it as I, j, k hat. For whatever reason, that's common notation. So I'm going to go ahead and use that notation from here on out. Okay, and why is this useful? Well, it allows us to specify direction separately from magnitude. And so this is where we get into the notation, the vector notation that we can express in terms of these unit vectors. So if I have some vector in space, A, and we're on an xy coordinate system, not to be confused with vectors here, these are the coordinate axes. And we've got our ay and ax component of our vector. So we can define these unit vectors along the coordinate axes, which this allows us to express our vectors as a vector sum, like so, of our components, so our scalar value component, and their direction. And so that's a nice way to look at this, because we're basically splitting our component and our direction. And since these have a magnitude of 1, and they're also unitless, they have no units, so they only specify the direction of where we're going. So if I read this out in words, we're going ax units to the right. So we have our ax and we have our direction, and then we're going ay units up. So if I had a triangle of, let's say this is 4, this is 3 or something like that, and this is a, we would say that a is equal to 4 I hat plus 3 j hat. And so that's the notation that we can use here with these unit vectors. Now if you're adding two vectors together, as another example, a and b, and you've got your ax and your ay component, and then bx and by, you would have your a as just this. Again, I won't rewrite it, but it's this equation. Then b would be bx plus by j hat. And then adding them together, you just combine the x terms and then you combine the y terms. That's ay plus by. And then that would give you your resultant vector like so. And so that's just an introduction to the notation that we can build off of these unit vectors. And that notation is probably the most important thing to take from this video, as it will become very useful in upcoming physics problems and more complex vector problems. So that's the notation of unit vectors that you can write out your other vectors in.